Right now, 3I Atlas is sitting at about 186 million miles from Earth. So this recent image was captured by an amateur astronomer on November 22nd using a half-meter telescope, which is a telescope that collects significantly more light than smaller telescopes, allowing it to see fainter and more distant objects. The image shows a bright glowing coma around the nucleus with two distinct structures extending outward. These structures are the comet's tails. This tail stretches away from the sun for about 3 million miles, and the other tail, which points toward the sun, is about 600,000 miles long. So to create a 600,000 miles long tail fighting against the solar wind, the material has to be incredibly dense. Loeb calculated that the mass density in the antitail needs to be about 1 million times greater than the density of the solar wind itself. So these tails are made of stuff evaporating from the comet due to the sun's heat. This process is called sublimation. At 186 million miles from the sun, the surface of 3I Atlas should be extremely cold. For carbon dioxide ice, which is the main volatile on 3I Atlas, the sublimation temperature is around -78 degrees Celsius. And to produce the mass loss rate we are observing in these November images, you would need about 620 square miles of active surface area, all sublimating at maximum efficiency. But NASA just released an image from the Mars Reconnaissance Orbiter captured in early October, showing 3I Atlas as a soft, glowing white ball. The image shows the cloud of dust and gas around it, measuring approximately 932 miles in diameter. Science says that this would makes sense if the object has broken into fragments, which often happens as comets hit their closest point to the sun. More fragments means more total surface area, but images from November 11th showed one single intact nucleus, no fragments, no debris cloud, just one solid body. 3I Atlas is way brighter than it should be at this distance after passing the sun.
Astronomers have achieved a major first. They refined the orbit of 3I Atlas using spacecraft orbiting Mars. By combining these Mars-based observations with data from Earth, scientists improved the comet's trajectory accuracy by nearly tenfold, the most precise path ever calculated for an interstellar visitor. The comet 3I Atlas was first detected on July 1st, 2025, by the Atlas survey in Chile. Within hours of its appearance, astronomers realized its motion did not match that of typical solar system comets. Its trajectory was hyperbolic, indicating it was unbound to the sun and passing through our system only once. Although numerous observations were gathered at early stages, astronomers still struggled to determine the comet's exact path with the precision they needed. A unique opportunity arose in early October 2025, as 3I Atlas passed roughly 29 million kilometers from Mars. The geometry between the comet, Mars, and Earth aligned in a way that made additional observations possible from a completely different vantage point. The resulting frames were not visually striking, but were scientifically essential.
NASA just released a fresh Hubble shot of 3I Atlas. This isn't a stacked composite or a long-processed mosaic. Basically the cleanest look we can get at the inner structure. And the first thing that jumps out is how sharp the core appears. Even after the brightening, even after the dust expansion, the center is still a tight, concentrated point. Here's the thing. For an object coming off perihelion, where thermal stress usually pushes things toward chaos, this level of stability is unexpected. While Hubble shows a calm, tightly held core, ESA's JUICE probe catches something completely different. JUICE wasn't expecting to see activity at this range, yet the structure jumps out even in a star-dense background. The alignment, the angle split, the texture, all of it points to ongoing outflow that simply doesn't show up in the Hubble frame because Hubble is zoomed tight on the inner region. So now you have two spacecraft telling the same story from different angles. One sees stability, the other sees motion. This object is active, directional, and rotating in a way that's not easy to classify. This object isn't quieting down, it's evolving.
Recent telescopic data shows not a smooth, passive ice ball, but a body scarred by extreme thermal activity. Scientists call them ice volcanoes. These cryovolcanic vents are rupturing the comet's nucleus, blasting massive jets of frozen carbon monoxide and water vapor into the vacuum. The analysis of 3I Atlas' latest images shows that it is spewing material plume, measuring hundreds of thousands of kilometers across.
November 27th, 2025. The United Nations activates the largest planetary defense exercise in history. NASA retasks over 20 assets. The European Space Agency approves €22 billion overnight. Official explanation: just a comet, no threat. Yet every alarm bell is ringing at once. If 3I Atlas is routine, why mobilize global defenses?